Precalculus 5th 6 weeks assessment 2019 selected problems. I intend this to be a very short video of some of the problems or types of problems that cause students most trouble on our most recent test. Problem 14, a spectator at a theater looks up to the top of a curtain on the stage that makes an angle inclination of 21 degrees above horizontal. If his eye level is horizontal with the bottom of the stage curtain, the height of the curtain is 12 feet. How far away from the curtain is the spectator to the nearest tenth of a foot? So we're looking at one of these text-rich problems that might be hard to make sense of, but a drawing, I find out, is most helpful in figuring out what happens. So you got a spectator here, and I'm just going to create like an eye, and the spectator is looking up toward the front stage to the top of a curtain. We are told that the stage, the angle of inclination is 21 degrees. We are told that the height of the curtain is 12 feet. Now, the question, how far away from the curtain is a spectator to the nearest tenth of a foot? And so here's the spectator, here's the curtain, and here's the distance, we'll call it D, in between the spectator and the curtain. So what this is, being a right angle situation, this is an opportunity to exercise the evaluation using trigonometric ratios. And so from this angle, 21 degrees, 12 is its opposite. So our opposite. And D down below is going to be our adjacent side. So for trigonometric ratios, we got two choices. We can use tangent of 21 degrees is equal to our opposite over our adjacent D. Now, one thing we can do is use our cotangent, because our cotangent of 21 degrees is going to be the reciprocal of tangent. So we can rewrite this as D over 12. And cross multiplying the 12, D is equal to 12 cotangent 21 degrees. Now, let's go look at this here. Go to our calculator. Here's our calculator. We'll do 12 first. 12 times cotangent. And we say it was 21 degrees? Yeah, 21 degrees. And we see our calculators in radians, so I need to get a degree symbol here to make sure that we get our calculation there. So we get 31.26, so the nearest tenth foot would be 31.3. You might ask that we do a lot of these problems in degrees, yet I keep my calculator in radians. Well, the reason I do that is primarily to try to reinforce that we need to continually look at what mode our calculator is in, and if it's in the wrong mode, in this case radians, we need to either change this to degrees or use our degree symbol to override the mode of the calculator. So I'm just trying to reinforce that recognition. So we get D is approximately equal to 31.3 feet. And so what we have here is, it looks like that's answer choice B. Okay, next. 18, arc of a circle has a central angle of 100 degrees. What is the length of the arc if the diameter of the circle is 14 inches in length? Okay, so we're going to give our answer nearest tenth of an inch and mark using the grid provided. Well, the arc length formula is S, the arc length, equals the radius times the angle. And our angle needs to be in radians. So our arc length is S, and our R, okay, we have a diameter is equal to 2 times radius, and 14 is our diameter, radius, and if we divide by 2, R is equal to 7. So we have S is equal to 7, and then we have our angle of 100 degrees. Well, the thing we need to have is this angle needs to be not in degrees units, but in radians. Well, to turn this into radians, we can multiply by pi over 180 degrees, and then we will have converted into radians. So we got our calculator, and we put in 7 times 100 times pi over 180, and for that we get 12.22, so about 12.22. And we want to the nearest tenth of an inch, so it's going to be S, it's approximately equal to 12.2 inches. And so using the grid provided, we put in 12.2. So here we have 12.2. Okay, next. 19, angle in standard position measures 330 degrees. What is the measure of its reference angle in degrees? Mark your answer using the grid provided. Well, a reference angle is the shortest positive angle to the x-axis. So if we have a xy coordinate plane like this, and we have a circle, and we have an angle of 330 degrees, that angle is going to end up about right here. So the reference angle is going to be, in this case, the difference between a full rotation, or 360 degrees, and 330 degrees. So we put 360 minus 330 is equal to 30 degrees. In degrees, okay, that'd be 30. We're going to mark the 30. If you perchance have to have an angle that shows up in standard position in either quadrants 2 and 3, you got to work with the 180. So if this was instead a 245-degree angle, you'd have to subtract 180. So 245 minus 180, that's going to be a 65-degree reference angle. If you had a 115-degree standard position angle here, the reference angle would be 180 minus 115 degrees, which would equal 65 degrees. Okay, so reference angles. Shouldn't be hard at all. The last one in this selected set is going to be problem 20, when the shadow length of the church measures 120 feet. And so shadow length, I saw some people writing the test, they're saying shadow length, well, that's 120 feet, right? Is that right? Is that our shadow length, 120 feet? No, it is not. Shadow length is along the ground. So we're going to mark 120 feet along the ground. That's where the shadow resides. So we got 120 feet there. We want to find the height of this church. And let me erase this here. Okay, what we have is a trigonometric ratio of tangent. So the tangent of this angle here, 55 degrees, is equal to our opposite over the adjacent side, 120. And so solving for h is equal to 120 times tangent of 55 degrees. Okay, let's look at that calculator. 120 tangent 55, and again our calculator's in radians, so we get a degree symbol to make sure we're going to get this right. So we get 171.378. Let's make sure I get this right. 71.378. And that's going to be in feet. And we want our answer to the nearest tenth of a foot. So h is going to be approximately equal to 171.4 feet, which we can mark here on our grid provided. 171.4. There's 171. And 0.4. Okay, this concludes our video on these selected problems. I hope this has been helpful to you. Good luck, and thanks for viewing.